Imagine that a family of 3, Alice, Bill, and Chester, play bingo at home every night. Each night, the chance any one player will win is 1/3. A. Using A for Alice's win, B for Bill wins, and C for Chester's wins, develop a tree diagram to show the 9 possible outcomes for 2 consecutive nights of play. So our outcomes are who's going to win. Our events are the first and second nights that they are playing. So in the first night, one possible outcome is that Alice could win, or Bill could win, or Chester could win. On night 2, if Alice wins, Alice can still win in night 2, Bill can win in night 2, or Chester can win in night 2. Even if Bill wins night 1, Alice can win night 2, he can win again, or Chester can win. If Chester wins night 1, Alice can win night 2, Chester can win again, or, oops, I should say Bill could win, or Chester could win again. It's easier if you just keep them all in the same pattern, so it goes ABC, ABC, ABC. All right, now we're going to look at the outcomes. The outcomes are each branch. So AA is one outcome. AB is one outcome. AC, BA, BB, BC, CA, CB, or CC. On each branch, or on each piece, it says the probability or the chance that any one of these players will win is 1/3. So we would label it with 1/3 under each piece, all the way down. And to find the probability of each one of our outcomes, we would multiply. So over here, to find this probability, we would multiply, oh now my thing moved here. We would multiply 1/3 by 1/3, which is 1/9. But all of them are going to be 1/3 times 1/3. So every single one has a probability of 1/9. It's just going to happen over and over again. Okay. Part B says, is the probability that Bill wins both nights the same probability that Alice wins the first night and Chester wins the second night? So we have Bill winning both nights would be represented by BB, and that has a probability of 1/9. And then it's also asking us about Alice winning night 1 and Chester winning night 2, which would be AC. That also has 1/9. So for part B, let's change that back to our pen. For part B, we would say that the probability is the same for both.